Yes. Let's go back to the question which we did yesterday. We can go back to the question paper and we can see question number 5. And question number 5 is talking about question number 2 to 4 again, where they wanted to find out the rate of descent to maintain the required glide slope with different ground speeds.
Yeah.
Are you on the page? So question number 5.
Yeah.
Right? So let's look at question number 5. Using the details in the question 2 to 4, what rate of descent is required to maintain the glide slope in each of the questions with different ground speeds? Yes, are you with me?
Yeah.
Yes. So let's go to question number 2. Question number 2, you are given, what is the glide slope given? Question number 2, the glide slope given is 3.5 degrees. The question number 2, the very first question. Second question. We are coming back to those questions again.
Yeah, 3.5 degrees.
3.5 degrees. And in that particular question, you're asked to find out the height 2 nautical miles from this thing. But now what we have to find is, on that 3.5 degree glide slope, look at question number 5 alpha. If you have a ground speed of how much?
120 knots.
120 knots. What should be the rate of descent is the question. So if I want to maintain 3.5 degree glide slope with a ground speed of 120 knots, which is displayed on your screen, the ground speed, what rate of descent should I maintain? Yes, I'll give you something 2 minutes and I'll come back.
So sir, for this we can first have the theta, that is the glide slope angle.
Yes.
We have ground speed we have as 120 knots, and we need to calculate the RD.
Yes, you said the question.
But we don't have the gradient.
Well done.
But we don't have the gradient.
Oh yes, unfortunately.
So we can calculate the gradient. So gradient we know.
Okay. Yeah. So you want to calculate the gradient. Okay, let's calculate the gradient. Are you there?
Yeah. So for gradient it's like So it's like the vertical height in feet divided by h, that is in nautical miles, the range, into 100.
That's correct. So for that, let's put a picture here. Straight.
Yeah.
The glide slope given is 3.5 degrees, and you're on a ground speed of 120 knots. You're intercepting this glide slope from somewhere underneath at 3,000 feet, and you are maintaining this. So what should be your rate of descent? So reduce the power, start descending. What descent rate should you maintain? Yes. So you are telling me we have to find gradient. Okay, let's find gradient.
Yeah. So we know that gradient is the ratio of vertical height in feet divided by range in nautical miles.
That's right.
Multiplied by 100 for percentage.
That's right. Okay. All right.
So I don't have height. That's vertical height I don't have. So I can consider a range of 1 nautical miles, and using the 1 in 60 rule, I can calculate it.
Yeah. So you can using 1 in 60 rule, you can calculate.
Directly also, if we say by approximation, we know that it might be around 350 feet.
That's right. 3.5 degree glide slope implies that 350 feet has to be lost every nautical mile. This is actually what you're trying to find out by applying 1 in 60. You will end up here with approximation.
Yeah.
Right? Yes.
Yeah.
Therefore, the gradient in percentage is how much?
So it's the height in feet,
which is
divided by
50.
That is 350 feet divided by 1 nautical mile.
One
nautical mile is 6,000 feet approximate.
That's right. 6,000
into 100.
Into 100. Yes. How much is that?
5%.
Yes. Accurately 5? It's something 5 point something.
Okay, I'll just take 50. It's 5.8.
Yeah. That's right. It's 5 point. It should be more than 5 because 3 degree glide slope itself is 5, right? So it's going to be 5.8% is the gradient.
8%.
Yes. 6%.
So I know that now I can easily calculate my ROD. So ROD is basically the product of, I can say, gradient. Gradient in percentage is equals to ROD in feet per minute divided by ground speed in knots.
That's right.
So ROD in feet per minute is equals to gradient, that is 5.8 multiplied by my ground speed. So ground speed in knots is given 120 knots. So 120 into 5.8. So 696 feet per minute should be my ROD.
That's it. So you can see for 3-degree glide slope, it's around 600 feet per minute. Therefore, it's more than that. 3.5 degrees, it's 696 feet per minute. You can round this off very well to 700 feet per minute. Nothing wrong in that. Right? Let's visualize the same thing in a different way. Alright, so you're looking at a ground speed of 120 knots. Now what are you asked to find out? You're asked to find out the rate of descent. Now what's the meaning of rate of descent? In feet per minute. Is the height
in feet per minute
in 1 minute.
1 minute, yes.
Right? So if it takes 1 minute for me to cover this distance, then this height which I'm supposed to lose is nothing but my ROD. So don't get confused. I'm representing something in feet per minute. What I'm trying to say is, if this is the height which I need to lose in 1 minute, then that is the rate of descent. Right? Yes. Now, if I have the ground speed of 120 knots, as we discussed yesterday, this is
2 nautical miles per minute.
Very good. So every minute you are looking at a distance of 2 nautical miles. So what is the distance equivalent of 1 minute here? That is 2 nautical miles. So 2 nautical miles away from the threshold, ILS threshold. Yes. So on a 3.5 degree glide slope, 2 nautical miles from the threshold, what should be your height? That should be your glide slope.
Approximate 700.
Multiply with
into 100 into 2.
Which is?
Approximate 700 feet.
Which is 700 feet. And that itself is your rate of descent. So ROD will be 700 feet per minute. You see, it's a different approach towards the same question. This is much more simpler.
Yeah.
Because here you're finding the gradient, which is not required actually. You can actually find it out by the basic understanding that rate of descent is a height to be lost in 1 minute. Now we have a connection between rate of descent and the glide slope. Only thing is the glide slope is expressed in nautical miles, and therefore somehow we have to convert this time equivalent to distance, and then it's just a glide slope problem after that.
Yeah.
Right? Yes, you can copy that also. So what did we do here? In the second case,
we actually calculated the speeds and the time required for that 1 nautical mile of distance.
That's right. Basically, we calculated how far are you traveling in 1 minute. So basically, if you have a ground speed, how will you calculate the distance traveled in a minute? By simply dividing it with
60.
With 60, right? So that is basically this distance of 2 nautical miles which you got here. And then how did you find the rate of descent after that from this? You multiply your glide slope, which is whatever glide slope you have, I'll take it as theta, with what? With 100. First?
With 100, that is for 1 nautical mile.
1 nautical mile. Then for so
and
much
then for how many nautical miles of range multiplied by that.
So that is ground speed by 60?
Yeah.
Which is the distance which you travel in 1 minute?
Yep.
Right? Alright? Happy? So you can see such kind of an equation floating around, which is ground speed into glide slope, multiply with 100 divided by 60, and people tend to memorize this to find out rate of descent. If you are good in memorizing, you can memorize it, fine. Otherwise you can simply just follow this and that's going to give you the answer.
Okay.
Right? You can just write down this equation also. Rate of descent is equal to your glide slope into ground speed divided, and there's some kind of rearrangement as well in this equation. I'm not an equation person, so I'm not sure how that is set. I think it is theta into ground speed into 100 by 60. That should be the way it's arranged. But yeah, I prefer just finding it because it doesn't take me maybe like 1 minute more.
Much long.
Just maybe like 10 seconds more to find, but this is more comfortable for me, so I'll probably do that. Yes, but you can keep this equation in mind. Alright, so let's look at the next question. On question number 3. Question number 3.
It's 2.6 degrees.
2.6 degrees. And what ground speed are you asked to consider in question number 5, Bravo?
180 knots.
180 knots, yes. So they were faster. Yes, so rate of descent.
Needs to be increased. Okay, so that's
The glide slope has also changed.
changed.
Right?
That is now 3. So that is basically now taking me 3 nautical miles per minute.
Yes, that's right. 2.6 degrees of glide slope. You're looking at 1 minute distance. Why are we looking at 1 minute distance? Because the height corresponding to 1 minute distance is nothing but the rate of descent. Right? And with, as you said, ground speed of 180 knots. Over 1 minute, what is going to be the distance covered? That is 180 divided by 60, which is 3 nautical miles. On 2.6 degree glide slope, 3 nautical miles the range from station. What is your height? Your height will be, take your glide slope, multiply with 100.
Into 100.
So we saw this 100 thing yesterday, if you remember. How this 100 came up? It was 6,000 by 60, right?
Yes.
Into your range, which is 3. How much is that?
It's 2.6 into 100 into 3. Like it's 260 multiplied by 3. So it's 780 something might be.
780 feet.
Yeah,
Right?
780.
So this is the height which you are supposed to lose in 1 minute. Therefore, this is also nothing but the
An
rate
ROD.
of descent.
Yeah.
Easy. Right? Your method of going through gradient is not wrong, but this is also right.
But that's like theoretically it's a very big way of solving
That's
it.
right. Yeah.
It will require much more time.
It will take more time. Correct. Yes. But you can think in that way there's something wrong. The same. What about Charlie? What is the glide slope that is given in question number 4?
It is 3 degrees.
3 degrees. And the ground speed is?
And ground speed is 150 knots.
150 knots. You have to find out rate of descent.
Yeah.
Right? You can find the rate of descent exactly the same way. Where you can find the rate of descent h on the same diagram. You can take your glide slope, which is 3, multiply it with the distance with 100, and then multiply that with the distance you would cover in 1 minute with 150 knots. That is 150 divided by
60.
60. So how much is that?
Yeah.
That's going to be.
It's 2.5. It's 250 is 750 feet.
Oh, okay. 750 feet. And this is the feet which you have to lose in a minute. Therefore, the rate of descent is equal to 750 feet
per minute.
750 feet in 1 minute. Now you see, the easier way to do this is whenever you have a 3 degree glide slope, your rate of descent is.
I have the gradient.
But ground
5%.
speed into the gradient, which is 5%.
Yeah.
And ground speed into 5.
Yeah.
So what is that? 150 into 5. This is 750 feet per minute. We can remember this because it's so much of time saving here. You don't have to do any of these things. Only for a 3 degree glide slope.